Hello there, I'm Will Patillo, and this is another Unity programming tutorial, this time on the subject of interfaces. And the way I'm going to be explaining interfaces and how they are useful is by building off of my earlier tutorial about inheritance and making the scene more complicated in such a way that the inheritance model starts to break down. And once it's clear where the limitations of inheritance start to show up, then I think it'll make sense to show how interfaces can be used to overcome those limitations. So we'll just get right into it. I'm back in my scene. I've added some more objects, as you can see, and a little bit of text here to describe what's going on. So on each of these objects, I can left click, right click, or hit the space bar. And also another constraint I've added to myself here is that I want the left mouse button to always be speak, the right mouse button to always mean walk, and the space bar to always mean swim. I don't want to change the UI controls for different objects for whatever reason. Maybe clarity to the user. Maybe it's based on the events that's calling them and it just doesn't make sense to change it. But anyway, I'm gonna go through this, see what happens. So bring up the console here because this is where the results are gonna be. So I click on this red button and there's a ARF. Blue button says meow. Right button doesn't say anything. Click on it, nothing happens. Left click on the light blue, eek, eek, eek. Right, the magenta, nothing happens. And the gray, you get a bleep blorp. In case you're wondering why these sounds, the red button is a dog, blue is a cat, yellow is a giraffe, light blue is dolphin, tuna, and robot. So if I go through these, the dog says arf, cat says meow, giraffe doesn't speak, dolphin says that, tuna doesn't speak, and then there's the robot. Now if I go with the right mouse button, the dog can walk, the cat can also walk, so can the giraffe, the dolphin cannot walk, neither can the tuna, and the robot can walk. Now for swimming, dog can dog paddle, cat cannot swim, giraffe cannot swim, dolphin can swim, tuna can swim, and the robot cannot. So let's take a look at, well, first the construction of the scene here. We have each one of these objects has a circle collider, just a sprite renderer, and an individual script for its type. So there's a dog, cat, giraffe, dolphin, tuna, robot. This _1 is just to prevent duplicate names because this is the same project as my previous tutorial was in. The rest of the scene, this is just a canvas for that text that was up there. And the player has a input getting script over here. So let's take a look. Let's look at the player first. Have an enumerated type called input. The same ray and raycast hits. We'll look at that later. And in update, I can get various number of keys. This is the left mouse button, right mouse button, space bar, the I key, or the A key. It's different things. Each one will cast a ray and it just sets an input. I could do this by getting rid of these lines and putting an argument in the cast ray, and in which case I wouldn't need this type out here. But I found it a little bit easier to just set the type and then use it so I don't have to deal with arguments. Anyway, when the ray is cast, look at where the mouse position is at the time of the ray cast. See if it collides with an object, and then if it does, then I go on to this act function. Now, yes, and this will pass in the animal component, because each of these scripts, the dog, cat, and so on, all inherit from animal. So again, using that inheritance as a switchboard, the player does not need to know what type of animal is acting. They just need to know that it is an animal. And then I use inheritance with these virtual functions to just make sure that the correct animal type does what it needs to. Okay, so you can ignore this plus equals for now in the speak count, walk count, swim count. We'll get to that later. The important thing is that in each case we look at what the most recent input type is. Again, that was set up here. And then call, and again it's animal every time. This script doesn't need to know what animal it is. And then has it speak, walk, or swim, depending on what was pressed. I'm going to take a look at the animal script next. Just some virtual functions that ignore this return 0 for now. That'll come up later. It just calls the speak, walk, or swim. This is our switchboard. And then, so let's say that the object is a dog. Then we have our override here. And in the case of a dog, speaking means saying arf. You can ignore the return 1. Walking means saying dog is walking, and swimming means saying the dog is dog paddling. Now, likewise, if I go to a cat, cats can only speak and walk. I did not include a swim function. Maybe some cats can swim, but this one can't anyway, or refuses to. And it inherits from animal, but this time it says meow and cat is walking. Now, the first thing you'll notice here is that since there is no public override for swim, this is starting to break the inheritance pattern just a little bit. Because it's not causing any errors or really any unexpected behaviors as yet. There's no major problems, but it's violating a design principle that's, I believe, known as the Liskov substitution principle, which is that any property that's possessed by an animal should also exist in all of its derived classes. You really should be using derived classes as extensions of a base class, not just ignoring things from the base class. But you can do this. This doesn't create any errors. So we've run into a little bit of a problem with inheritance already, but nothing too big just yet. Next, I go to a giraffe, and this one's different still. It only has walk. It doesn't have speak or swim. So another dolphin script. This has speak and swim, but not walk. And tuna only has swim, but not speak and walk. And then we get robot, which, kind of like the others, it includes some of the functions but not others. But here we're getting our second sort of problem with inheritance, at least in this example, that we want to inherit from animal because we want to make use of this switchboard mechanic of being able to call it from here without necessarily knowing what script is attached. So being able to inherit from animals is very useful, but just conceptually, a robot isn't an animal. And so when you say it inherits from something, you're saying that a robot is an animal, even though it isn't, which is kind of weird. However, those are both just kind of conceptual problems. Neither of those really create code errors or anything like that just yet. I suppose it could get progressively weirder if we had more robots and other non-animal things that we wanted to include in this, and eventually it would get confusing. But instead, I'd like to point out something that actually is a little bit more of a challenge, is get into this speak count, walk count, and swim count. If I bring up my scene again, I run it, and I click around and press some buttons here and there, and I get some space bars in there too. And then I press the A key, then I get the total number of times that any of the animals in the scene, or entities in the scene, have spoken, how many times they've walked, and how many times they've swum, or swam, or one of those. And the way I do that is, so when, here's my getting the input, and this time, rather than calling the animal, I'll just go to get action count right down here, and then I look at speak count, walk count, and swim count, which were declared up here as integers. And the way I get the correct numbers for these is with this plus equals. So if I take a look, let's see, you got animal, and then say go into dog, here's where these return ones come in. So from the input, get animal speak, I go to animal, this gets overridden by dog, it returns a 1, which goes back to animal, which returns that, which returns the 1 again, back up to player, so it goes down 2 deep and comes back up to 2 layers to update the speak count variable. If on the other hand I call speak on something like giraffe, well then it still gets called up here, and then it goes down to animal, and this time, since giraffe doesn't have a speak method in it, I use this return 0 here. So this is our default for the speak action if it doesn't get overridden. So if it is overridden, return 1. If it's not, return 0. So this works, as you just saw, but it's a little bit awkward, in part because it's coupling together all of these scripts. Robot, tuna, dolphin, giraffe, cat, dog, animal, player, every single one of them interacts with speak count, walk count, and swim count in some way. So they're all kind of tied together, and making changes to cat, like if I return 2 here, would effectively change how player works. So that could very easily cause problems later, especially if this were a much more complex example and had a lot more things going on. Maybe the names weren't quite as descriptive, so someone might change something not realizing what it was actually being used for. So yeah, it'd be nice if we had a better way of doing this, of just updating speak, walk, and swim entirely in this input script, and not having to reach down into animals and to specific animals within that. So all 3 of these problems, the issue of the, some things not including overrides, the issue of having this robot that doesn't really fit an animal, and this extra complexity that we have here with getting these counts, all of these get solved if we change this into an interface model. Now, before I get into the code and the scene where I'm using interfaces, I'd like to bring up a conceptual distinction between these 2 methodologies of programming. So over here on the left, I have an inheritance model, or a graph of it. So at the center, I have my base class animal. So cat inherits from animal, dog inherits from animal, giraffe inherits from animal. In other words, a dolphin is an animal, a tuna is an animal, a cat is an animal, a giraffe is an animal, and then also a robot is an animal, even though it isn't, but never mind. In contrast, over here is kind of how I would draw up the way composition works. Here you see there's no animal class. There's nothing that things inherit from. Instead, you have groups, and these groups are separated by the behaviors that they have. So we have a speaking group that contains cat, dolphin, dog, and robot. We also have a walking group that contains cat, dog, giraffe, and robot. And finally, a swimming group that includes dolphin and tuna. Groups can overlap. A single object can be contained in one group or multiple. It doesn't matter. So as you can see here, there's everything either belongs to each group or it doesn't, and there's really nothing here that's particularly awkward about it. There's nothing weird about saying that a robot can speak and walk, or that a tuna can swim but can't speak or walk. It's a fairly natural grouping that mirrors the way these things work in the real world. So that solves problems 1 and 2. Now let's look at how it actually works. I get out of this scene here, go into interfaces. First I'll run through it to show that it works. Okay, I got my speak, applies to some of them but not others. My walking also only applies to some. And spacebar, dog can swim, cat cannot, giraffe cannot swim, dolphin can swim, tuna can swim, robot cannot. So it's working the same way. Oh, and then also if I press A, I get my total 4 spoke, 4 walked, 3 can swim. Great. This is organized a pretty similar way. I have an input script for the player. And again, individual animal scripts for each animal. Take a look at the player next. So in player, it's set up fairly similar in terms of getting input with my cast array and keeping track of the numbers. Cast array works the same way. And now in act what happens is when I get this animal passed in, I check whether the animal that has been selected has a speak interface. And if it does, then I call that speak method and then update my speak count right here. And then a break, since this is a switch statement. Same thing for if I press the right mouse button. Check if I can walk, and then if I can, walk, and update the walk count. And for spacebar, swim, same thing. This is commented out for now because I'll get to it later. And so the first thing we'll see right now is that since speak count, walk count, swim count are all updated in the input script, and this is also where the get action count is called, I've solved the third problem because I don't have to look at or reference anything in the animals or the individual animals to update my counts, because it's all handled right here. So there's no coupling or dependency that doesn't need to be there. Let's get into our animals. Let's take a look at dog. Another thing you'll see here, so this inherits from monobehavior because there is no base animal class. And the reason I'm using monobehavior is so I can make use of these debug log lines. And instead, I implement multiple interfaces, which is one of the things that make interfaces useful, is that there's no limit to how many you can implement. With inheritance, you really should just be inheriting from one class. But interfaces don't have that restriction. There's no reason not to have many of them. Also, another thing that you don't really get the effect of it in this simple of an example, but say you imagine each of these methods was hundreds of lines long, and there was lots of other methods going on in here. If I just open up this dog script and I want to know whether it can swim, I would have to scroll all the way through it to see if a swim method's present. I mean, I could just Control F search. It's not that big of a deal, but it isn't immediately obvious. Whereas here, since I have this I speak interface right at the top, same I walk, I swim, I know what its capabilities are as soon as I open it. Same thing for other animals. Let's say I take a look at the tuna. This only has swim, and so I know that immediately. Now, the one other script that is here is interfaces. This again is like the animal script, is not attached to any object, but is just implemented by the scripts that are attached to objects. This interface is very simple. This is actually 3 different interfaces, but I just put them all together in one script for organizational purposes entirely. They could be in separate ones. So interface public, and it just contains an empty method for speak. Since each of these only contain one method and no variables, I just put them all in line. It's not necessary to only have a single method in an interface. For example, if I had something like public interface I damageable. Oh, by the way, this I am putting in front of each of these is a naming convention to signal to your reader that what they're working with is an interface. They put this I here as a bit of a visual cue. So if I had I damageable, then I would probably put in it something like void take damage, and this would probably take in a int hit amount, for example. So I damageable interface would also likely have a void die, which wouldn't have to take any arguments, and possibly some other methods as well. So what an interface basically is a contract that says that any thing that implements the interface must have all of the methods that are described in the interface. So that's the cost. That's what you're giving up in order to use interfaces. And the benefit, what you gain from taking on the responsibilities of this contract, is the switchboard effect. That I know that any animal which has the I speak interface must have a speak function. Therefore, I can simply call speak, referencing the interface, without knowing what script is attached. Whether it's a dog, whether it's a cat, whether it's a giraffe, whether it's a dolphin, whether it's a tuna, whether it's a robot, if it has the speak interface, it can speak, and therefore I can call speak on it. Now, one question that might come up is, well, if interfaces can solve the same kind of problems as inheritance, and it has fewer limitations, and in fact, conceptually, most things in the real world follow this are closer to following this pattern of overlapping groups than they are, rigid hierarchies that inheritance models. This is a little bit more of an artificial way of arranging things. So then the question could become, well, why would you ever use inheritance? Well, the reason for it is because in certain situations, inheritance can save you a fair amount, can be a lot easier to implement, and can be less repetitious. So that gets into these commented out sections that I have. So I'm going to look at this interfaces version of it first. So I have this input type here, I, for identify. So what that does, so using the interface model, I have my own interface here of interface ID, which calls the identify method in each animal. And what the identify method does, say if I look at it in dog, okay, have it implement that interface, is it simply says I am a, and then gets the game object dot name. So this will say I am a dog. Same thing if I go into tuna, identifies itself as a tuna. If I go into all the others, it's the same thing. And one thing you may notice is that in each case, it's doing exactly the same thing. The exact same code, the exact same interface. Like, this is a literal exact cut and paste. And you know, whenever you're cutting and pasting significant amounts of code, you're probably doing something wrong. And this is already, just going through this is feeling rather repetitive. In contrast, if I go back up to my inheritance example, I'll uncomment out some of the things here. To get the same identify method to work, all I have to do is, so here I get the case input I, call identify on animal, and then on animal identify, says I am a game object.name, and it'll work regardless of what animal it's attached to. It'll work exactly the same way. And if I look in my individual animals, let's take dog for example, identify doesn't need to be in here because the base class takes care of it just fine. This does not need to be overridden. You'll notice that all of these are virtual methods. This one is not. This is your typical public void identify. And because this is a case where it actually follows this pattern. Everything is exactly the same. It follows it, and so by using inheritance, I can just put things up on this base level, and I don't have to cut and paste repeatedly. Use the same code over and over again. This can also be very nice if you're dealing with a base class that includes lots of different methods, and like 90% of them are the same on the base class level, and then 10% need to be overridden. You know, why go to all the extra trouble of putting interfaces in there or making the entire thing interfaces when you can get most of the work just here and then override when you need to. So basically, the kind of cases where you would use inheritance instead of interfaces is when you know that certain features are going to be in common and that's not going to change at any point. And in particular, when the derived classes are like extensions of the base class. So for example, if it was like a car and then I wanted to have a red car and a blue car and a green car or something like that, I'm just like adding a layer of paint to something. That's kind of a place where I would likely use inheritance. Interfaces, on the other hand, are cases where the objects you're working with don't necessarily hold things in common, and it just makes more sense to put them in groups. But that's kind of an organizational question and kind of almost a philosophical one when you're organizing your project and planning it out. The big takeaway, if you don't get anything else out of these videos, is what inheritance and interfaces have in common, why you would use either of them. And the big reason for it, once again, is that switchboard mechanic. To be able to call from somewhere else, whether it's through getting, the interface, checking whether it has an interface, or whether it's just calling the base class, to be able to call a method without having to type check. And both of them do that. So because there's so much overlap between these design patterns on the mechanical level, it was actually a bit tricky for me to come up with a good example that differentiates between the two. So if certain things about this still don't make sense, please feel free to ask about it in the comments. Hope you learned something, and if you did, don't forget to like and subscribe. And until next time, I'm Will Patillo, signing out.